Welcome to Understand the Math. Before you begin, be sure to check out the video description below for a link to free guided notes that you can download and fill in as you watch this video. In this video, I'll explain what the law of sines is and go over 3 example problems where the law of sines is used to solve a triangle. The law of sines is a trigonometric law that relates the lengths of the sides to the sines of its angles. It's used with an oblique triangle like the one shown here. An oblique triangle is any triangle that's not a right triangle. The law of sines states that the sine of angle A divided by A, the length of the side opposite angle A, is equal to the sine of B divided by B, and that's equal to the sine of C divided by C. We can also write this as A divided by the sine of A is equal to B divided by the sine of B is equal to little c divided by the sine of our angle C. This first box is a version of the formula that you would use when you're going to solve for angles. And the second version is the version that you're going to use if you're going to solve for sides. You can use either anytime. It just makes the algebra easier if you use the first one when you're solving for angles and the second one when you're solving for sides. I'll now quickly go over how to derive this formula. If you're not interested in the derivation, just skip to the next page where I'll go over steps for solving a triangle. Let's first number these triangles. This will be number 1, and we'll call this triangle number 2. I'm going to use the first triangle to show that sine A over A is equal to sine B over B. If we use right triangle trigonometry, we can say that sine of capital A is equal to the opposite over the hypotenuse, so that's h1 over b, and that tells us that h1 is equal to b times sine of A. Likewise, we can say that sine of our angle B is equal to h1 over A, and that tells us that h1 is equal to A sine B. We can then equate the h1s, and that gives us that B times sine A is equal to A times sine B. If we divide both sides by A and B, that gives us our formula. Sine A over A is equal to sine B over B. I'll now use the second triangle to show that sine B over B is equal to sine C over C. Again, using right triangle trigonometry, we can write that sine of B is going to be h2 over C. So h2 is equal to C times sine of B. Likewise, sine of capital C is h2 over B, which tells us that h2 is B times sine capital C. Equating these, we get C sine B is equal to B sine C, and dividing both sides by B and C, we get sine of capital B over B is equal to sine capital C over C. And then when we connect these two formulas, we get the formula that we had at the top of our page. The other formula that we're going to use along with the law of sines is the formula that states that all 3 angles of a triangle have to add up to 180 degrees. So we can write that as A plus B plus C has to be 180 degrees. We'll use this when we know 2 angles and we need to find the third angle. The law of sines can be used to solve a triangle. That means we can use it to find all the sides and all the angles of a triangle. To do this, we need to know 3 parts of the triangle. Those 3 parts are going to be a combination of angles and sides. Two of the parts need to be a side and an opposite angle. And I'm going to highlight that because that's extremely important. In our first 2 triangles listed here, we can't use the law of sines because these 2 triangles do not have a known angle and an opposite side. So we'll put an X by these 2. For these types of triangles, you have to use the law of cosines. The law of sines can be used to solve triangle 3 and triangle 4. The reason for this is both of these triangles have an angle and an opposite side. We'll highlight those. So this is our opposite side and this is our angle. And this angle we can find using the fact that all 3 angles have to add up to 180 degrees. And then in this triangle, we have a side and an opposite angle. In our 5th triangle, we sometimes can use the law of sines, and this is called the ambiguous case. I'm not going to go over that case in this video. Let's write a sometimes for this one. Let's now go over 4 steps for using the law of sines to solve an angle-side-angle triangle, like number 3, or an angle-angle-side triangle, like number 4. The first step is to assign variables to the given side and angles. Second step is to assign variables to the unknown angle and 2 sides. The third step is to find the third angle using the formula that angle A plus angle B plus angle C is 180. And then the last step is to find the 2 remaining sides using the law of sines. I'll now go over 3 example problems. This triangle is an angle-angle-side triangle, so we know that the law of sines applies. Let's just remind ourselves that when we solve the triangle, we're going to find all sides and all angles. Our first step is to assign variables to the given side and angles. I usually like to start with angle A on the left just because it makes sense to me. So I'm going to do that. So we'll call this angle A. We'll call this angle B. And then we notice the 44 is the side opposite angle A. So we're going to call this little a. Next, we'll assign variables to the unknown angle and 2 sides. At the top, we're going to have angle C. Opposite angle C, we have side C, and then opposite angle B, we have side B. For step 3, we're going to find angle C. So we know that A plus B plus C is equal to 180 degrees. So we know that C is going to be 180 degrees minus A minus B. After you do a couple problems, you can just jump right to that part. Our angle C then is equal to 180 degrees minus 29 degrees minus 51 degrees. This gives us 180 degrees minus 80 degrees, which is 100 degrees. So let's go ahead and let's add that up into our picture. Our last step is to find the remaining sides using the law of sines. So let's notice that we need to find side B and side C, and we know side A. Since we're trying to find the sides, we're going to write down the law of sines like this. A divided by sine A is equal to B divided by sine of B is equal to C divided by the sine of C. Let's now plug in the values from our picture. A is 44. Capital A is 29 degrees. And then B is what we don't know. And then we have sine of capital B, which is 51 degrees. And then C over sine of 100 degrees. Let's first solve for B. We have 44 divided by sine 29 degrees is equal to B divided by sine of 51 degrees. If we multiply both sides of the equation by 51 degrees, we get B is equal to 44 over sine 29 degrees times sine 51 degrees. When you throw that in your calculator, you end up with a value of B equal to 70.53. Let's now solve for our side C. We have 44, again, divided by the sine of 29 degrees is equal to C divided by sine of 100 degrees. Multiplying both sides of the equation by sine 100 degrees, we get C is equal to 44 divided by sine 29 degrees times sine 100 degrees. And that gives us an answer of 89.38 when you throw it in your calculator. This triangle is an angle-side-angle triangle, so we know that the law of sines applies. We'll begin by assigning variables to our given sides and angles. We'll let the left angle be A, the right one be B, and then the side length is going to be opposite our angle C, so that is equal to small c. We'll then assign variables to the unknown angle and two sides. So our unknown angle is going to be C. Our side opposite angle A is little a, and our side opposite angle B is little b. We'll start by finding angle C. So our angle C is 180 degrees minus A minus B. So this is 180 degrees minus 29 degrees minus 51 degrees. This gives us 180 degrees minus 80 degrees, which is 100 degrees. We'll now find sides A and B using the law of sines. We'll start by writing down our formula. A divided by the sine of angle A is equal to B divided by the sine of angle B is equal to C divided by the sine of angle C. I always tell students to write down the formula first, and that really helps to memorize the formula if you have to memorize it, because you've been practicing it with every example problem that you do. Let's now fill in the information from our triangle above. A divided by the sine of A, which is 29 degrees, is equal to B divided by the sine of 51 degrees is equal to C, which is 10, divided by the sine of angle C, which we just found to be 100. We can then solve for A. I'm going to skip a step because this is very similar to what we just did in the previous example. So we can say that A, multiplying both sides of the equation by sine 29 degrees, A is equal to 10 divided by sine 100 degrees times sine 29 degrees. When you throw that into your calculator, you end up with an answer of 4.92. To find b then, we can say that b is equal to 10 divided by sine 100 degrees, and now we're going to multiply by sine of 51 degrees. And the calculator gives an answer for that of 7.89. Our last example is an application problem. I always tell students when you're doing an application problem or what we would call a word problem, the best thing to do is to read through it once first. So you might want to stop the video, read through this problem once. Then read through it again and highlight or underline information that you're going to need. We have a satellite orbiting the Earth that passes directly over observation station A. So we'll highlight station A and observation station B. At a moment in time when the satellite is between the two stations, I've drawn a picture that kind of shows us that. Its angle of elevation is simultaneously observed to be 70 degrees and 60 degrees. If station A and B are 300 miles apart, and let's also underline A and B because they name the station, how far is the satellite from station A? Let's underline that in red because that's what we need to find. We'll start by putting the information that we highlighted into our diagram. We have observation station A and observation station B. We have two angles of elevation. The first one is 70 degrees, and because they talked about station A first, the 70 is assumed to be the angle of elevation at station A, and then the angle of elevation at station B is 60 degrees. And then lastly, it says station A and B are 300 miles apart. So this distance is going to be 300 miles. The next step that we'll do is we'll assign variables to our unknown quantities. We'll begin by saying the satellite is located at angle C. Likewise, the side opposite C is little c. So little c is 300 miles. And then we have a side opposite angle A and a side opposite angle B. We want to find how far the satellite is from station A. So that means what we're solving for is our variable little b. This is an angle-side angle triangle, so we can use the law of sines. So our first step when we use the law of sines is going to be to find the unknown angle. Angle C is equal to 180 degrees minus A minus B. So this is 180 degrees minus 70 degrees minus 60 degrees, which is 180 degrees minus 130 degrees, which gives us 50 degrees. Let's add that back up into our diagram. Angle C is 50 degrees. Let's now write down the law of sines. And we're solving for a side, so we're going to write it as A divided by the sine of angle A is equal to B divided by the sine of angle B is equal to C divided by the sine of angle C. We'll highlight in yellow what we want to find, and then let's highlight in green what we actually know. We know angle A, so we can find sine A. We know angle B, so we can find sine B. And we know angle C, so we can find sine of C. And then we're given length C, so we know that one. This tells us that we're going to use this part of the formula to find our side length B. Let's go ahead and fill in those values. We have B divided by the sine of angle B, which is 60 degrees, is equal to side length C, which is 300, divided by the sine of angle C, which is 50 degrees. If we multiply both sides of the equation by sine 60 degrees, we end up with B is equal to 300 divided by sine 50 degrees times sine 60 degrees. When we throw that into our calculator, we end up with a value of 339. Since this is an application problem, we always want to write down our solution in sentence form. So we'll write down our answer as the satellite is 339 miles from station A.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.